Welcome to C# for Crestron programming. In this tutorial, our objective is to learn about one of the most important pillars of object-oriented programming called polymorphism. So, the natural question to ask is, what is polymorphism? Polymorphism refers to something that can take on more than one form. From a theoretical concept, polymorphism can be difficult to comprehend, but we will explain it from a very rudimentary point of view. Polymorphism refers to an object's ability to take different forms. A child object can be accessed the same way that its parent object can be accessed, however, with different characteristics of the parent object. In object-oriented programming, polymorphism helps driven child objects to have methods with the same name that is declared in the base object parent. Polymorphism is unbelievably powerful and makes our code extendable. It gives great flexibility for program to call the correct method, depending on the type of object that is used to call it. By using a keyword virtual to invoke the appropriate method on any driven object through a single call to a base object method. Once again, remind you that the terminologies objects and classes used interchangeably here. Every single class or object defined by us or predefined in the libraries of the language has a default parent class, that is, the object class of system in namespace. Anyhow, we discuss some of these concepts in object or class discussion tutorials in detail. Polymorphism can be expressed as static polymorphism that occurs at compile time, and dynamic polymorphism that occurs at runtime during application execution. The best way to explain polymorphism is starting with a demo project in Visual Studio 2019 community version. A typical classic example of polymorphism probably related to something like this code. In this code, polymorphic behavior of a shape object, how it behaves to draw various other shapes. We have a program class. Then we create parent shape object. Then we declare a draw method and indicate with WriteLine method to console window. Notice the keyword virtual within the parent object, this keyword essentially giving permission for child objects to override the inherited method. Next, we inherit from shape object into circle object. Same thing, we define a method for draw, but pay attention to override keyword here. This keyword allows to override the method that has been inherited from the parent object. We continue with another inheritance from shape object into rectangle object. Same block of code with keyword override for the method and output to console window. Next, we instantiate these objects under main method, which is the entry point to our program. Shape C equals to circle, open, and close parenthesis, and we end it with semicolon. Next, same thing, but this time for rectangle object. Shape R equals new rectangle. Then we call these methods by c.draw and r.draw. This is a very classical way of explaining polymorphism. We should explain this concept from an AV perspective and understand the concept deeper. Without further ado, let us start another Visual Studio project with console application. In this example, let us add and define new base display object, which will be our parent object in a new file. I labeled my new class to be base display. Then we will have a property with string type name and a method called powerOn. Public string name get set. This is essentially creating a property for name. Notice the keyword virtual, void powerOn, open, and close parentheses in string device. This is essentially the base method for powerOn. Then console.WriteLine with some string, sending powerOn command for device, and pass into argument. I want to create another class or object. We go to Solution Explorer, right mouse click on the project name, Polymorphism, then add class. Give a name, call it projector. Now, let us inherit from base display. Notice the inheritance notation, colon. As soon as we inherit from base display, we are automatically inheriting properties, methods, whatever we defined under base display object class. Next, public override void power on, open and close parentheses, string device. This is the method override. Now, you might be wondering why we are defining to be override. Well, in base display class, we define the method with a keyword virtual, right? This is sort of permission to child object to overwrite this method, whatever the child object would like to do. Now, child object has the luxury to override, tweak the method based on its own consumption. Remember, when there is a change to method within child object, the base object knows this, because when child object tries to use this inherited property and method implicitly defined, the base display constructor is called. Why? Because the property and method inherited from the parent base object. We then output to console window with some text sending power on command for argument 0, device. Some comment here, wait until projector turns on. Another console.writeLine with some text sending lamp query command for argument 0, device. Alright, let us define more object or class. Call it TV display. Next, let us have TV display inherit from base display. Again, this object is inheriting the property name and base method power on. No other code needed here. Finally, let us go back to our program.cs. This is where our main method is, and code a little bit more. Under main method, first we need to instantiate these new child objects so that we can call the methods. Base display myproj equals new projector. Base display myTV equals new TV display. Let us now assign name to myprojector and myTV. Next, let us call the power on method under myproj and myTV. myproj.poweron, open and close parenthesis, myproj.name, and mytv.poweron, open and close parenthesis, mytv.name. Finally, console.readKey, and don't forget the using directive for our custom library to allow the use of types in namespace container. This is just a sneak preview of polymorphism, and we will further explore this concept more in depth in future tutorials. Polymorphism allows us much more code reusability. We learned that polymorphism has inheritance, method overloading, method overriding techniques to fully appreciate the power of polymorphism in C# programming. We also learned that using keyword, virtual, on the parent object and override on the child object. Thank you for watching.